Hello, everyone.
Hi.
Welcome to ITS140 again. Okay, so today we are going to get started. So again, given that you have your exam one on Tuesday from 12 to 1:40, you will, I'm not going to assign a homework this week, but instead we're just, kind of taking it slow today. If you have questions about anything, let's go over them. Type of a review, if you will. Otherwise, I'm just kind of going over, this is the chapter that I'm discussing this week, repetition structures or iterative structures, right? Loops, basically. And additionally, we can do a few problems. You do have a homework assignment due tonight, right? Which is the modules homework. Remember that those, I get so this question so many times, and it's so repetitive. So the questions, if I give you an assignment, the questions, I will provide the PDF, right? A PDF or some Word document or something with the questions for the. So as I was saying, I get this question all the time. If I assign a homework, I will provide some kind of a PDF or a Word document. You just have to look for it. So sometimes I may put it here, or sometimes it's just going to be in the module itself because I don't want to put it in two places, right? So it's there, I can reference it. So you have to check the materials. You should be reading all of these anyway, right? Your slides. You need to be reading all your slides, and the problems are there. So sometimes what you can do is follow by page number. So if it's like problems 1 through 9, and you get to problem 6 and you can't find it, just look at the page number. The next page will have the next problem, right? Even though the pages might be the way that I made the copies might be in a different order. So please, definitely when you're doing this, check so that you find the problems right there. All right, so as you know, I've graded this one, input processing. I'm going to be grading the next one, decision structures, just the if statements. And we will be using if statements quite a bit as we go forward. And then this is due tonight, modules. So make sure you submit that. And then we have, as I said, iterative structures. There's no homework for this yet. I plan to continue this topic next week on Thursday. We'll do more, and then I'll assign the homework then. So today, I'm gonna open it up just first, so that if you have any problems in particular, any questions, so we can go over that. If not, I'm just gonna continue going over iterative structures. We might do a problem with those, etc. So are there any questions? If you can mute your microphones, please, if you're not going to ask a question. All right, so are there any problems in particular you want me to look at? No questions? Is everything clear? Okay, well.
Yeah, I have a question. For problem 2, they wanted us to reuse the same tax program as we did in chapter 2. Do you still want a flow chart for that one too?
Well, I mean, if it's the exact same thing, you don't have to do it again, right? You could also just copy paste it from the previous one there, or you could just say, this is the exact same thing. If you believe, like if it is your belief that it's the exact same one without any differences, yeah, just say it's that one, or you can copy paste.
Okay.
Mm-hmm. Any other questions, guys? No? All right, well, seems like there's no questions. So then, let me see. Let's see if there's anything here worth doing. So let's just go over the slides then. Let's go over the slides. Okay. So you should now be seeing the PowerPoint slides. So we've talked about this. We started these on Tuesday. And I believe, let's see, I think we did this. We looked at that one. We talked about infinite loops. I remember that. And I started talking about this. Oh yeah, I remember doing this for loops. So, you know, one of the basic structures in and for pseudocode, do we write pseudocode for each function in a module? What do you mean by that? I mean, you should always, I mean, if code is required, you have to write it, right? Do we write pseudo for each function in a module? What do you mean by that? I'm not too clear what you mean by this question. You know, whatever code is necessary to complete the task, just, you know, you have a problem, you have to solve it, right? So solve it. And that means, you know, write as little code as is necessary, but you have to solve it. That means, you know, I would recommend that you write the pseudocode and the code itself. I mean, that's the whole point of this, is that you write the flow chart, the pseudocode, and then the actual Python code. Does that answer your question? Okay, all right. So, you know, as we will learn later on in Python, in the beginning, everything is pretty much a list. In the beginning, there's obviously other things to consider later on as you add libraries. But in particular, everything is considered a list. Python is very object oriented. So what that means is that lists can contain just about anything. So here in particular, you know, whenever we iterate, we're iterating through this list of things. So I gave this analogy of a bucket full of tennis balls, right? And so that's really kind of how it is. You know, you can think of whenever you're doing these kinds of things here, right? You know, it's like a container, a box or something, a bucket, but it's full of things inside that you're kind of, you know, grabbing and can only grab once, right? And so that's the analogy, and they're in a sequence also. So first you grab the first one, then you grab the second one, then you grab the third one, and so on. So to accomplish, I think this is kind of where I stopped on Tuesday. So usually in the for loop, you use what is called the range function. So you can think of the range function as, you know, it's a function like other functions that we have already started to talk about, but it's a built-in system function. Whenever you call it, the range will give you in return a list. And again, a list, just think of it as, again, as a bucket full of objects. But they're in sequence, so it's more like a pipe, I guess, with tennis balls in it. And then we can grab these items out of that in sequence, okay? But this is the approach that you follow in Python for loop. So for instance, in C, you do things like for I equal 1, where I less than or equal to 10, I plus plus, right? And then you do something like that, and then your curly brackets and your statements go in there, right? And we can do that same thing in Python by using this mechanism, the range function. So now in Python, what we're gonna do is we're gonna kind of write it, but we're gonna say for I in range, and then we just specify in the range all those parameters that we want. So for instance, you know, and this can change quite a bit, so it might be confusing to you initially because range is a very versatile function, and it can take, you know, one parameter, it can take 3 parameters, you know, so we could say just 10, and we're gonna iterate 10 times, or we could say from 1 to 9, and we're just gonna iterate in that range, or we could say, and I'm gonna need more room here, we could say from 1 to 20, step 2, right? And so we can actually do in steps as well. So there's a lot of flexibility, versatility really, to do a lot of things with this in Python. Okay, any questions about that? All right, so using the range function with the for loop. Okay, so the range function simplifies the process of writing a for loop. Range returns an iterable object. Okay, so that, you know, I called it a list, and here, you know, this is saying that this is an iterable object, which is the same thing. It's basically an object, could be a list, right? And iterable just means that it contains several items that you can iterate over. So iterable contains a sequence of values that can be iterated over, okay? And so that's kind of the definition of that. Okay, so the range characteristics, okay? So you have, as I said, 1 argument, 2 arguments, 3 arguments. So 1 argument uses, used as ending limit. So basically by default, you really just need 1. You know, it'll assume that it'll start at 0, right? So it'll assume that it'll start at 0, and then it's just going to continue iterating until it hits that ending limit. You can have 2 arguments, the other approach I indicated, where we have a starting value, you have a starting value, and you have an ending limit. Okay, so now, you know, you could do things. You can even go in reverse. I mean, you can do a lot of incredible things in with Python. You have 3 arguments, right? And that's, oops, it's not working. All right, 3rd argument is what is called the step value. All right, because you don't always have to iterate by 1. You can sometimes iterate by 2, by 3. There might be some situations where you want something like that. Okay. So we'll see obviously examples of that, you know, soon enough, either today or next week. Using the target variable inside the loop. The purpose of target variable is to reference each item in a sequence as the loop iterates. Okay. So that's, you know, that idea that you have some variable for I in, you know, range, you know, so this the target variable. So the target variable can be used in calculations for tasks in the body of the loop. All right, so example, calculate square root of each number in a range. All right, so you have a list of the numbers in the range, and you can calculate the square root of them. So you have something like 4, and now notice that variable can be anything. So since this talked about each number, okay, well, I'm just going to call it number then, or number in. So this can always change. For number in, and then now you have here the values in that range, which would be 2, 4, 3, whatever, or in order. If it's something returned by range, right, it might be 2, 4, 6, 8. All right, so now what this is saying is you can take that, you can use that, this variable here to calculate the square root. So now you're going to say, let's say result is equal to, and then now, math, for instance, math dot, math dot square root of number. So it's like, I always think of this, again, I go back to this idea of, and I don't know if this is a great analogy for you guys, but I go to this idea of the bucket, right? So then you have the tennis balls in there, which are really the numbers, right? So we have 2, 4, let me put them in sequence. So let's say 2, 4, 6, 8. And then the number is your hand, Oops, a terrible hand. Like that. There's skeleton like hand. All right, so that's a hand. So number, is the hand. So basically the hand grabs that and you have possession of that in number. And then you use it. Next iteration, it's like number is gone. And now the hand, which is, the hand is number, grabs the next one, 4. And so it takes it in here and then there, right? And then the next iteration, the hand, which is number, grabs 6, and now it has it, and so on. And then the last iteration, the hand, which is number, grabs 8 and uses it in the square root. You see that? So that's kind of the mechanism that you have in Python. And that right now might seem kind of crazy when but the key thing is that when you do these for loops, they are actually, as was stated in the previous slide, it is an iterable object. It is an iterable object. So you'll learn later on that you can have anything. So you can say for keys, for keys in dictionary.keys. You'll see this later on, right? When you have a dictionary, the dictionary has like, for every value in there, there's a key. And so you can grab all the keys, and the keys are not necessarily in a sequence, right? There might be dispersed there. And so, this is just whatever, an iterable object. But when you use range, it just so happens that range returns an iterable object of usually of numbers in some kind of a sequence. Okay, does this make sense, guys? Okay, so, yeah, go ahead. Make sense? Are there any questions? All right, it doesn't seem that there's any questions. Let's go ahead and continue. All right, so letting the user control the loop iterations. So sometimes the programmer does not know exactly how many times the loop will execute. Okay. Can receive a range inputs from the user, place them in variables, and call the range function in for clause using these variables. So be sure to consider the end cases when the range does not include the ending limit. There's a few tricks to that as well. How to exit or continue in a loop, continue the iterations, but not continuing the code there. But it just adds a little bit more logic and control to your for loops. Now, we will look at this probably later, not right now, but there's a few functions out there like break, continue. And, right now we're not going to cover those so much, but I encourage you to play with these as you start doing your loops to figure out how they work. You use either break or continue in the for loop and see the behavior that you get. Okay. Usually they need to be associated with some kind of an if statement. So you're going to say, if condition so-and-so break. If, like if somebody is in an infinite loop, right? And then you can say, if they've iterated for more than 10,000 times, break, and just some kind of a mechanism like that. All right, so as I was saying, one of the great things about Python is the use of negative indices. So the negative index has various implications in Python that are very interesting. Here, for instance, we can use the range function to generate an iterable object or a list, of objects, which are numbers, because, variables are objects too, right? They have properties. They're just specific types of objects that can store information or numbers. So generating an iterable sequence that ranges from highest to lowest, okay? That's basically, something in reverse, right? So that's also possible in Python. We can generate, a sequence of descending numbers, right? So at some point, we'll look at some sequences, okay? One of the different problems. So I'm trying to think of a scenario where we would do negative numbers. Like a countdown maybe, or would be something where we would do negative numbers. Well, I'll think of something, but the range function can be used to generate a sequence with numbers in descending order. So you make sure starting number is larger than the n limit, so you can see that here. So it's going to go from 10 to 0, and the step size will need to be negative. So it's basically like you're subtracting. Okay, it's going to be subtracted. Calculating a running total, that's a good example for us to do. We might actually do one of those today. Would be fun to practice one of those. As I said, I'm not too concerned with covering everything today, given that you don't have a homework assignment for this yet, because you're studying for your exam on Tuesday. So we can see here, programs often need to calculate a total of a series of numbers. Typically include two elements: a loop that reads each number in series, and a variable that we call the accumulator. Now the fact that it's called the accumulator does not mean that it's some special type of variable in the system. It's just any kind of variable. You just, because of what it does, you call it an accumulator. So, usually there's two words we kind of semantically use. They don't really exist in the language, but you just give them that name usually, and pretty much everybody knows what they are. So if you say something is a counter, it basically, it counts things like +1, right? So the example of a counter is like I equal I plus 1, right? So, you know, you're counting up, counting down. An accumulator is just, the only difference really is that instead of a +1, it might be a +x, all right? Because x is whatever, whatever, some value other than 1. So for instance, in here in this running total, I'm assuming you're entering sales for the day. So then sale, right? And you input. So we'd say like input, right? In the input prompt, sale. And so the employee of the company would enter a sale into X, and then X gets added into this, and that's why it's called an accumulator. Known as program that keeps a running total, accumulates total, and reads in series, okay? At end of loop, accumulator will reference the total, and and that's basically the general idea there. All right. So here, calculating a running total, kind of what I was saying. So set accumulator to 0. We start there. Is there another number to read? No, then you print out probably accumulator, right? So print accumulator. And then, or if there is a number to read, you read the next number as input, that variable X that I told you about, and then you add the number to the accumulator. So that would have been the I, or well, here I'll use the terminology. So it would be accumulator accumulator equal accumulator plus X. Okay, that's kind of the general idea. And then you keep iterating. You go back over here and then back over here, and you keep in that sort of loop like that. Any questions so far? No questions? Okay. So it seems like you guys are really understanding this. Usually or you're very shy. Students usually have, a few more questions. But maybe you just get it all. That's good. I mean, Python itself, I don't need to sell it. It sells itself. I mean, it's, I can't say enough about Python. Usually, I think you guys will use Python quite a bit. Even if you're not programmers of like video games or whatever, system administrators, you would use the language quite a bit. Okay, so we'll see an example of that. I mean, what would you like me to do? Tell me what you would like to see. What problem? Just an accumulator? Somebody asked a question, so I'm just, all right, in the chat. Okay, do you want me to do it in the Jupyter Notebook, or do you just want to see pseudocode? Which one? Jupyter, all right. All right, so let's do an accumulator in Jupyter. So I appreciate this, actually. This is what I want you guys to sometimes do a little bit more of. Just ask for problems, because otherwise I just assume everything is just clear, right? So let's bring up our Jupyter Notebook here. And we're gonna do a accumulator. All right, so I'm going to the folder. I need to share this. All right, so you should now be seeing the Jupyter Notebook. So I'm going to open up just a new one here. All right, so I'm talking about this accumulator, right? So what I mean is we're gonna do a running total. So code for a running total. So now I'm going to do, you know, let's say we're going to make up a scenario. You work in a store, right? You work in a like a fashion store, right? And you sell sweaters or something. And so you have all the receipts for the day, right? You're kind of a small operation, mom and pop shop. So really it's kind of like two independent systems. You have all the receipts now for each transaction, and you want to enter them into your system, for instance, right? So that's kind of the idea. And you wrote a script that does that for you. It allows you to calculate things. It would probably write to a database, although obviously we're not going to do that part because we haven't covered databases. But you can do that in Python if you didn't know that. So you could just easily make a connection to a database and write over there. So let's see. I want to do, you know, I don't have to call it accumulator. Remember, I actually want to call it sales total for the day, you know, something like that, or for today. Okay, and you need to initialize it to 0. Now you could also do this, given that, you know, you could end up with like, you know, fractions, right? You know, real numbers, because it's, you know, they never round out to 0 necessarily. All right, and so now we have this, and what do we need? We need a for loop, right? So we talked about how we have whiles, but in this case, we have the for loop. And then now I'm gonna do for, and now you have to think, right? So is the appropriate thing to use a for loop? Is the appropriate thing to use maybe a while loop? You know, which one do you use, right? So let's think of, just very easily, you know, just do a simple one. So let's say this is the simplest I can think of. We're going to say print, you know, enter number of transactions, right? So you're going to enter the number of transactions first. So then we're going to create a variable, transactions, right? And it's just going to be input. And then you're just going to say, I'm going to have, you know, 4 transactions, okay, or 5. I have a batch. When I say the word batch, I just mean I have a set of things. I have a set, you know, I have a stack in my table of 5 receipts, right? So that's a batch of 5. All right, so I'm going to do, I have transactions. So now I can do for, and then I can say for I in range, right? And then we can specify, well, transactions. That's it. It's as simple as that. However, you could also do, you know, I guess more explicitly, you want to start at 1 comma transactions. You could do that. It's entirely up to you. You don't need to use a step size in this one. But don't forget the colon, hit enter. Again, you know, I know Jupyter does this for you, but sometimes get into the habit of just like going there and then doing 1, 2, 3, 4. You know, I like to do 4. Some people do 2, 1, 2. What I don't like about this is that the code is harder to read. So if you don't, you know, if you have great eyesight, I guess do 2, but you know, it'll help you out if you just do 1, 2, 3, 4. You know, it's a little bit more indented, a little bit easier to read. certainly get, you know, when you're coding, get a big monitor. Don't use a TV, you know, that they're not the same. Get it, like, you know, invest in a good monitor. They're pretty cheap. Get a big screen, protect your eyes. All right, anyway, so for I in range transactions, and then now what are you gonna do? You wanna enter the transactions, right? So then probably another print statement. Now, usually here, remember, I don't like to write all the code up at once. I just like to kind of write a little bit and make sure it works. So that's what I'm gonna do. So I'm just gonna say print, you know, enter transaction total, right? And then what I like to do sometimes, I do several tricks, but let's do this one, right? So this should print something. So let's we can save it, and then let's run it. All right, and so I'm going to enter. I don't want to enter too many. I'm going to enter 4, right? 4 transactions. Hit enter. Oh, and it gave me an error, and it says, "What's the error?"
It read it as string.
Read it as string, right? The common error that we do all the time, right? So, or that we get all the time. Okay, so 4.
I think it needs to be in like an integer. It's saying the string cannot be interpreted.
Oh, I'm sorry. Did I make it a string? Yeah.
Yeah, you just casted it wrong.
I'm not even paying attention. I'm sorry, guys. Yeah. All right. So I think all right. So yeah, you're right. You're totally right. Okay. So let's go ahead and try again. 4. There we go. All right. So that's usually what you want to do, right? You know, I like to do this just little by little, right? I add a little piece, run it. I know it's running. So that way I know that what I've written so far is good, and then I can just start adding to it. So now, what do I need to do? I said enter transaction total, or you could say enter transaction receipt or receipt total. You know, it's up to you. You know, what you do there. Now here, you can then do, what do we need? We have already sales total for today, right? So we can say current value, for instance. Okay, and then we have an input, right? And then, come on, you guys tell me now, how do I complete this running total idea? How would you do it? Come on. I showed you in the slides, right?
Take the current value that take your current value variable and add that to your sales total for today variable inside the loop.
Inside the loop. Okay. So let's do what she says. All right. So I need to. You said I'm going to literally follow what you say. You said take the current value and add it to sales total.
You would write that line as sales total for today plus equals current value.
Plus equals. So let's not go that far yet because it's a little bit more sophisticated. But so is that all I need to do here? How would you like more easily write it? Easy to read without doing that plus or equal, because that's something I haven't introduced to the other students. So how would is this enough, or do I need to do something? Anyone?
You would write it as sales total for today equals current value plus sales total for today, if you don't want to do the plus equals.
Yeah, not yet.
Okay.
We'll get to that when we get to that in the slides, then I'll introduce that. But I'll be honest that even when I write programming code, I like things so clear. But there is an advantage. What she's saying is you do something like that, little tricks like that. They have efficiencies in the way that this could be faster, for instance. They have efficiencies. So there's definitely a reason to do it, but it's something that I don't want to throw in right now. And let's just keep it completely clear. So do you think this will work?
It should.
It should, right? Very good. Good answer. Now, usually, as a convention, you probably want to write it like this. Okay, it's just that, the other way would have worked, but it's just more of a convention. Sales total for today is going to be equal to sales total for today plus the current value. Now, don't forget, even though in Python you don't have to declare variables, here you definitely have to initialize it. If you don't, you're going to have a problem. So just be aware of that. So now, since we are entering the values, I want to print out the sales total for today and view it, right? So you guys tell me, where do I put that? Where would it go? Anyone?
Kind of cut out. I didn't hear the rest of your question.
So now I'm done, right? I'm going to enter a few transactions, and then I want to print the total. How do I do that?
So can you print sale total? So hit print sale total of the day is, comma, then put sale total.
Where do I put that? Like where in the code? Here? Like where my cursor is? Do I leave it there?
Nah, I'll probably space one out.
Like down here, you mean?
Yeah.
Okay. Here then. All right, so that, so what might be the problem with this? Is there a problem or will this work perfectly? Is it a problem or maybe just aesthetically, maybe you would want something else? What do you guys think?
Should you move the print back?
Back where?
Like just hit backspace so it's not indented?
Why?
I don't know. I just feel like it should be.
You just feel, yeah, well, if there's different behaviors, right? So let's kind of look at it actually and, why we would want to do that. So if I do, let's just do that. If I do run, I just want to enter 3 transactions. Enter transaction receipt. All right, so I'm going to make up some numbers here. 1550. It gave me an error. What's the error?
You're reading it as a string instead of a float.
Exactly, right? The same one. So now here, do I make it int?
Yes.
Yes. Or no?
Yes, you should make it an integer, right?
I'm going to make it an integer if you say I should make it an integer. All right. So let me try this again. Three. So how about I try something else?
Yes, try float next, right?
Let's try this one. Ah, okay. What about, okay, now, I don't know, for whatever reason. And then, okay. Is it, first of all, is it running? Is it working? Is it doing the correct? Is 1550 plus 1236 plus 1477, is that equal to 4262.99? Yeah. All right, so that's one way of doing it. And it might just be a preference, right? So maybe that's the way you guys want to do it. Or maybe you just want to see the total at the end. Either one, right? So it could be that you actually want to see the totals as you're adding them for work, just to make sure that it's working. But you may actually also just want to see it at the very end. So that's certainly a possibility. So let's do another one over here. I want it 3 and I got 3 transactions, right? I'm gonna do 4 this time just to show that it can work with a different one. So let's say 11, 11. 13, 11. 14, 11. 15, 11. Oh, no, sorry. That's 1, 2, 3, 4, 49, 53, 53, 54. Good. All right, and you just see the total ones at the very end. And that's pretty much it. You know, that's a very simple accumulator, but it illustrates one use, one of many, many, many uses of for loops. Are there any questions? Guys, any questions?
So why could the transaction be an integer while the current value has to be a float? Just because it's the decimal in it?
That's a good question. So transactions meant the number of iterations. So usually I would have done 1 iteration, 2 iterations, 3 iterations. I'm not going to do 3.7 iterations. Do you see that?
Yeah.
So that's why transactions is an integer, whereas current value needed to be a float because I was entering values like 11.11, 13.11, 15.11, and so on. Do you see that?
Yeah, I got it.
Yep, good, excellent, excellent question. Any other questions, guys? Somebody asked, so whoever asked this question initially, does this, would you let, is this clear now? Do you want to see another example? I don't know why I have so much trouble opening this chat. It's almost impossible for me to. I don't get it. All right, I can't open it, but so any questions?
He asking the question of how you put sales total for day equals sales total for day plus current value.
Say that again. Is that a question?
The question in the chat was, how did you put sales total for the day equals sales total for the day plus current value?
I mean, how do we do this part here?
You don't understand how you're getting a value to get the value.
But you get it now?
I don't know. He put it in the chat.
Oh, he put it? Okay. So
He just put that in chat.
He just put that in the chat. I'm not seeing that question. I don't.
Yeah,
know.
he said, can you explain the sales total for today equals sales total for today?
Can you explain the sales total for today equals sales total for today?
I think he's probably just wondering why you would do that.
Why we do this?
Yeah,
because you're doing a running total, right? So you're reading in every iteration, you read something into current value. The next iteration, current value gets overwritten, so it's gone, right? But you want to know how much money you made that day. So if you had 5 transactions and you have 5 receipts, and each receipt was different, like 1111, 1311. You're reading those into current value, but you need to have a variable where you accumulate all of them, where you're adding them up, right? And you have that running total. So that's where the variable sales for today comes in. So sales for today is initially 0, right? And current value in the first iteration is going to get a value. So it's going to be 0 plus 1111, giving you sales for today 1111. So now sales for today is 1111. In the second iteration, sales for today is now the previous value 1111. You read the new value, which was 1311, right? And so you're going to take 1111 plus 1311, add those two, and put them in sales for today. And that gets stored because it's, it's out here. So now it's going to be, whatever that is, 2422. So then you do the third iteration, call the equation again, you check, okay, what's in sales total for today? Well, it's these two added together, 2422, plus what is the current value? Okay, I'm going to read in 1411. So now I'm going to add 1411, which is in this one, to what I already had, these two added together, 2422. So 2422 plus 1411, and now it gives me sales total for today again, and so on, until I get to the end. And that's why I'm able at the end to print out 5344, because it's what I've accumulated as I'm reading in the transactions. Does that answer your question? Okay, let's see. Okay, I was just confused because there was 2 sales total. Where's what do you mean there's 2 sales totals for today? There's only one variable called sales total for today, which is that one. But then you use it here, right? Which means it's like a bucket, right? You have a bucket, and initially in that bucket you put a 0. But then, you grab that bucket again, and now where you had a 0, now you're going to throw in you throw in $11 in there, really, right, in the bucket. The next iteration, you grab the bucket again. Now you had the 0, but that was nothing, right? So you had no money in there. But then you had $11 in there. In the next iteration, now you have 1311, so you throw 1311 in the bucket. So when you grab all your dollars in there, you have 2422. Next iteration, you grab 1411, you throw it into the bucket. And then, so you do that every iteration, you're just throwing money into the bucket. And that's the analogy. And then at the end, in this print statement over here, you just look into the bucket, and now you have 5344. But it's always the same variable. You know, think of it as a bucket, right? And you start with an empty bucket, and then every iteration you're throwing money into it. Which money? This money that you're grabbing from the input, and then at the end you just print out the bucket, or look at the bucket, or however you want to think of it. Does that make sense? Okay, all right, so I think that makes sense. You know, great questions. Is there another question? So, okay, so it doesn't seem like there's any question. So we can, you know, we can always come back to Jupyter. I actually want to do one new thing. Let's do another one. And this one, I just want to show you something interesting with Jupyter Notebooks. I'm going to do, this is that iterable object that it was talking about, right? So a list of, you know, it can be whatever you want, but let's say a list of numbers. And notice that I'm going to do this. I'm just going to put in 7, I put 11, 3, 17, 7, 13, 5. What are these numbers?
It's a list, right?
Yep. But what are these numbers? I think 19 also. All right. And actually here, this should be square brackets. Notice that I'm putting in square brackets. So these I think are all prime numbers, right? So they're not really a sequence.
I would say odd. I think odd numbers.
But yeah, but they are prime numbers, correct? Unless I'm making a mistake, I believe all of those are prime numbers. Numbers divisible.
Yeah, they are. By one in itself.
Yeah, one exactly. So just prime numbers, not even a sequence 2, 3, 4, 5. You know, I'm just trying to illustrate, you know, something, right? So a whole bunch of prime numbers. And now in the for loop, I'm going to try to do something different. So I'm just going to I'm going to do 4, and I'm just, you know, this variable can be anything. So, you know, why not prime, right? Why not? For prime in, and now here we usually put in range, right? That's what we've been seeing. But remember, range is just a function in Python that returns an iterable object. So if that's the definition of it, why not just plug in any other kind of iterable object, such as list of numbers? I mean, why not? There's nothing wrong with that, right? And so you can see now, that's why I use this analogy of the bucket, right? So if this is a bucket full of prime numbers, or a pipe full of prime numbers in that order, that's the one thing that is important. It does have that order. Then I can just take that bucket and just put it there, and it's not a problem. And then think of prime as your hand, the hand, and so the hand is going to grab tennis balls from that bucket or that pipe, if you want to call it a pipe. And that's the idea. So now what I want to do is I'm going to just print out the numbers, right? So I'm going to do a print, and I'm going to do prime, right? And basically, hopefully, my goal is to print out these prime numbers. And then after that, you know, that's it. And so I just wanted to show you this property, given that the slides mention this idea of iterable objects. All right, so I'm going to go ahead and run it, actually. What do you guys see? You see that it actually iterated through the contents of this, right? So it printed 11 first, then 3, then 17, then 7, 13, 5, and 19. So as you can see, that for loop is not just a for loop of numbers that follow, 1, 2, 3, 4, or whatever. It's a lot more than that, right? It's really about whatever you provide as a list of things, it can literally iterate through them. Does that make sense, guys?
Yep.
Sorry?
Yes.
Okay, great. Let's try another thing. Let's do another even more interesting little trick. List of string. All right, so now got my square brackets there again. And now I'm just going to plug in Mary, Bob, Alice, Zelda. Right, so I have now a list of strings, right? Strings, and so I'm gonna do the same. I'm gonna iterate through these list of strings, and over here now, because I want my code to always make sense. These are no longer prime numbers. What are they? They're names, right? So why not call them names? But you're not grabbing all names at once. So then just call it for name in list of strings. And so now I'm going to print out name. So this is the power and versatility of Python. So now we can go ahead and just clear everything. All right, and we can try this out then. Run, and you can see that it can also just iterate through that Mary, Bob, Alice, Zelda. So again, you can think of list of strings as a bucket or a pipe full of tennis balls with the names of these people. Those are the objects. And then just a key thing is that they are in like a sequence in order, and you can grab them with name. Name becomes the handler, as it's called, for the given item that you just grabbed. Does this make sense, guys? Are there any questions about this idea?
So do Python know like those are names, or just because you said 4 names, anything in the list of strings was considered a name? Like if I put tree in the list of string, would it think tree is a name because I said 4 names?
Those are just for you. So I could have written here, instead of name, I could have said, dog, right? Just whatever. It's the name that you give it. And so it's going to work just the same. So if all I have to do then here is, so Python doesn't have the intelligence to know the meaning of the word, of the letters DOG in that order. You do because, you're intelligent, but the Python doesn't know. To Python, it's just a variable. So if I just do this for dog in list of strings, print dog, it's the same behavior. So I can go to the kernel and do this one and then run it, and it just does the same thing. But if you did this and you worked for a company and you wrote that code and then you left for a better job and somebody comes in and they read your code, they're going to be like, for dog and list of strings, what does that even mean? You know what I mean? So it's not going to make sense. But if you wrote for name, print name, they'll be like, okay, name. And then, oh, these are names. Okay, so that makes more sense. It's just, this is almost like the idea of adding comments, right? So, you add comments in Python. This is a list of names. So maybe we should have called this list of names too. It's just ways of making your code more readable and clearer for people. Did I answer your question?
Yeah.
Okay, great. So yeah, these are, this is just, these are the amazing things that you can do with Python. Another question, let's see. Okay, let's see. What if you, so I get, so I'm gonna read the questions that I have in the chat. So there's, what if you add numbers into the list of strings? Would it still print everything in order, or would it skip over numbers and only print the strings? All right, that's a very good question. First of all, so that's actually a good question. So here, there's two things. If I do this, even though it's a 7, because it's in double quotes, Python is going to treat it as a string. Okay. Now, the more important question is, if I do this, will Python like it? Because if I do that, I'm actually building a list where, or let's call it an iterable object, where I have 4 strings and 1 number, 7. You guys see that? Now, Python, since it's just printing, it's going to treat that as a 7. Right? It's going to treat it as a 7. No question about it, as a string. But the question is, would it, if the data type is 7 here, would it still be a number? So obviously it can't do any math operations with these, right? But what about this 7? So here, let me just do the following. So I'm trying to do this in a simple way that doesn't require too much complex code. Let's just do it out here. If I do temp equal 3 times, and then I want whatever's in that list at position 7, right? So actually you have to, this is more advanced because this is like arrays, but let's just say this is 0, this is 1, so I want 2. So that's going to be list of strings, and then I'm going to specify position 2. So that would be 7, hopefully. So let me print it out first of all to see if I do get 7. And what I'm trying to show is what would happen by default with that if that 7 is considered a string or an integer. So let's do this one. List of string is not defined. What do you guys think? You see what I did? So without you understanding, don't worry so much about understanding like indexing and things like that, because it's a topic we haven't covered. But the student had a good question, right? If I put a 7 in there, what's going to happen? Well, it treated the 7 just like a string. Notice it printed Mary, followed by Bob, followed by 7, followed by Alice, followed by Zelda. So literally, what this means is that you could have written here John or 7, and it just treated it the same. If this was John, where you have a 7 here, you would have gotten the word John. You put 7 here, it just converted it to a string and printed out 7. However, when I directly reference just that object, and I did a multiplication times 3, I didn't have to typecast it to integer, right? It immediately just treated it as a number, and I was able to perform 3 times 7, which is 21. So then in temp, I have 21. So when I print it out, temp, I got 21 first before the for loop. You see that?
Yeah.
So that was.
So we're just gonna add in. They're just gonna change any number that's in the list to an integer, just because it's a 7.
Well, because of the double quote. So I want you to notice that this has double quotes in it, or sorry, does not have double quotes. So it just, you can have an iterable object or a list here of different types of data, strings with integers, and it was able, just because the double quotes were not there. If I do this, oops, sorry, if I do this though, that means I have now made that 7 a string, and that's a different problem. But before, where we had it like that, it's just an integer. And actually, you know, because the Jupyter, for instance, here, or Spider, or whatever ideally you're using, it's gonna put it in color green, so it identified it as a number, versus when you have something in double quotes or single quotes, it's a string. Any other questions, guys? Other questions? No questions? No? All right. So it seems like it's making sense. It's good. Would you like me to do another exercise of any kind, or go back to the slides?
Maybe another exercise.
Okay, another one. What do you want me to do?
So for the loops,
Uh-huh.
I want for the loop. So let's say I had to have the program keep doing, like, adding numbers until I got 17.
Got it. So you want it to stop at a conditional type of a thing, right?
Yeah.
Yeah, I get it. All right, that's a good one. Let's see. You need to have some stopping criteria, right? There's got to be some stopping criteria. The simplest. Let's start with something as simple as possible. You know, while, that's going to be the structure, while, and then we're going to say while value not equal 0. Okay, keep going. That's going to be our idea. So then again, we have our running total. Right, we have a running total over here, and then I'm going to say print, you know, please enter current value. And then we're going to say input. And this is going to be a float, right? Because it could be decimal. Oh, let's not call it in. Let's call it value, actually. And then we're going to do input. All right. And now value, now initially value needs to be something, right? So that's where we're going to run into the problem here. So actually, if I do this, oh, I got it. you don't actually have negative transactions, right? So then if you enter -1, now we'll have to think about the data type. So that's certainly something to consider. Value initially 0.0, right? Should be float, I think. You're now going to enter negative transactions or negative values until you want to stop. So then we're going to say, we have the running total. So now I got value, and I'm going to say running total equal running total plus value. And then at the end, you're going to just print out the result. So I'm going to say print running total. What do you guys think? Do you think this is going to work? Let's try it, right? That's a great thing about programming is that we can always just try it. All right, so I'm going to do something easy to add. 2, 3, 4. What is that? That's going to be 7, 9, 1. So that should be 10. And then I'm going to enter now -1. Let's see what happens. Didn't work. It actually subtracted, right? So now let's switch this over to 0.0. -1.0. Because it, oh, no, actually, did it stop? Oh, it did stop. Hold on.
It was
Yeah,
running, wasn't it?
Yeah, it stopped, right?
Mm-hmm.
Let me, actually, I didn't notice that. So let's try it again. All right, so I'm going to run it. 2, 2, 2. So it should be 6, and it should stop and print 6. Because I'm going to enter -1. Okay, so it does stop because it gives me the total, but it is still adding that -1 at the end. Do you see that, guys?
Yeah.
So there is that little, so we're almost there, right? We're almost there. We are definitely stopping it, which is good, which is what we wanted. Now we just need to get rid of the fact that it's subtracting -1, because we don't want that. -1 is just meant to be a stopping criteria. It should not be considered in the operations. So what are some suggestions? And here we could write really elegant code, or we could just, you know, kind of like hit it with a hammer, but get it to work. So what do you guys, I'd like to see it, any ideas that you might have to solve this actually. So what do you think? What would you recommend? Any suggestions?
Oh, you already equal to. No, never mind. That's not gonna work.
Suggestions? What do you guys think?
I'm trying to think. I don't know. Maybe if we make it to a greater than equal to thing instead of like a if not.
The problem is we just want to stop it, right? But we don't want to add that last one, that -1, because the -1 we really just want to use as a stopping criteria.
Can we add a if?
Ah, an if. Okay. All right. I like where you're going with that. So where do I put that if? We want to avoid adding when it's a -1, right? So then maybe if value, right, not equal to -1. So if value is not equal to -1, what do?
Stop running.
Huh?
Stop running.
No, you stop running. Yeah, here you stop running. But this one is just about adding. So when value is not equal to -1, so when the value is like a 10 or a 5 or a 6, what do we want to do? Do we want to add or do we not want to add?
We do not want to add. No, when it's a 6, we do want to add. My bad.
We do want to add. Very good.
Yeah.
1, 2, 3, 4, right? So when value is not equal to 1, if value not equal to 1, okay, like if this is a 2, 2 is not equal to 1, so this evaluates to true, which means we're going to add. But in theory, if value is -1, it's not gonna add. All right, so let's try it. So usually what I recommend here is just run it and convince yourself. Right? So we're gonna do again, try it out. 2, 2, 2, -1. Boom. Is it correct now? It is, because we stopped it and we also got the total that we were looking for. 2 plus 2 plus 2 should be equal to 6. Any questions about this one?
Oh, I got it.
Got it? All right. Excellent. All right, so that's an approach. All right, so let's see. We can go back to the slides now, and so I'm going to share. Maybe there's a question. Nope. So let's go back to the slides. There we go. So we were there, I believe. So we went over this. So somebody had asked when I was going over this, let's do examples in the Jupyter Notebook. So we did. Okay. Now we are going to continue. And these are, what Emily was talking about, right? The so-called augmented assignment operators, which you don't have to use, certainly not in this class, but you can if you'd like to. All right, so the augmented assignment operators, in many assignment statements, the variable on the left side of the operator also appears on the right side, right? We've seen that quite a bit, right? When we do, it appears here and here, right? So it appears twice. You can get rid of that if you'd like. Augmented assignment operators, a special set of operators designed for this type of job. or also called shorthand operators. Okay. So the augmented assignment operators are this convention, right? So, you know, I write x equal x plus 5, but you can also write that way, right? So it's kind of the idea that because it's this, you just do x, you know, it's x plus 5. But then you don't want to do that, so then you kind of merge these two, right? And then the plus goes before, like that. And that, you know, does the job. Okay, so these are called the, as I said, the augmented operators, and you can apply it to all the different operations. If you have plus, plus, minus, minus, times, times, this is division. This percentage one is the modulus operator, mod, which is the, when you have a remainder, if you don't remember, like 20 divided by 3, right? So you do all the operation, and at the end, you get a remainder here. And that's what modulus gives you. So this has some applications sometimes, especially in math, cryptography, things like that. But you actually also use this a lot whenever you want to print things. You don't want to print every index. You just want to print like every 100th or 1,000 operation. That can be very helpful. All right, so then, yeah, those are the assignment operations. In this class, I'm not gonna require you to use either that or that. I leave that to you as your personal choice or preference. You know, programming is a lot about style and preference sometimes. You know, this, in some languages, this can be faster just because of the way it's implemented. But, you know, in what we're doing, you know, nothing requires really speed or precision, so we don't have to worry about it. All right. Are there any questions about these? Okay. So then, sentinels. Right? Sentinels are special value that marks the end of a sequence of items. Right? Kind of like the -1 that I used. You know, same idea. When a program reaches a sentinel, it knows that the end of the sequence of items was reached, right? And the loop terminates. Must be distinctive enough so as not to be mistaken for a regular value in the sequence. You know, very much like when you're doing transactions, you're not going to enter negative numbers. Example, when reading an input file, empty line can be used as a sentinel. Okay, all right, so we haven't talked about files yet, so don't worry about that. We will talk about files later, though. Okay, so that's the idea. Input validation loops. Input validation is very important for quality and for security in any type of software development. And input validation loops are the kinds of loops where you just say, okay, you know, if you enter a value and it's not right, then the program kind of evaluates it and says, okay, that was not the right value, please enter it again. So you're going to enter a loop until the program determines that the value you just entered is the correct one. Okay, so it's a type of loop as well, logically speaking. We will cover that. So if user provides, so your computer cannot tell the difference between good data and bad data, right? So the computer cannot tell the difference between good data and bad data. If a user provides bad input, the program will produce bad output. And that is usually referred to as garbage in, garbage out. You'll see that term quite a bit You know, if you don't know the data that you're entering, you know, the program will process whatever you give it, right? Because it's not smart, right? It's not a person. And so there's this phrase, garbage in, garbage out, and it just implies that, you know, you need to make sure that it's not, the inputs are not garbage, but they're actually good inputs. So it is important to design a program such that that input is never accepted, right? Now, input validation is a simple thing to do, but it can be a lot of work. It's not necessarily hard per se, but it is, you know, it's just an additional thing that we, you know, usually we want to solve the problem, so we're not always thinking about validating our inputs. All right, so input validation loops. Input validation is inspecting an input before it is processed by the program. If input is invalid, prompt the user to enter correct data. Now, this can be commonly accomplished using a while loop, which repeats as long as the input is bad. If the input is bad, you display an error message and receive another set of data. If input is good, you continue to process the input. And here again, we gotta stress the flow charts, right? So we got our get input over here. Is input bad? Obviously, we can't just say that on the computer, right? We have to define it in some way. If it's not bad, we would continue to the next instruction. But if it is bad, we need to display that there's an error message, and we need to get an input again. And then we go over here and back. And so we're in this loop, kind of stuck in that loop until you provide the good data that the program is looking for. Are there any questions about this? No questions? All right, so let's keep going. Nested loops. Ooh, this one's a fun one. Nested loops. But nested loops, I am actually going to save for next week, because even though we only have like a slide or two here, might be a little bit more complex. So instead, let's just, in the time that we have left, let's go back to our Jupyter and let's just think of input validation. Okay, let's just think about it for a little while. I'm going to switch over to Jupyter. All right, and I'm just going to create a new one here. So, input validation. What do we want? What do you guys think? What's the scenario? Something simple. Okay, I got it. Let's say that we want something related to temperature, right? Fahrenheit. So you need to enter an appropriate temperature. So I'm going to say temperature equal 0.0, because it could be 73.5 degrees, I suppose. And then we're going to say while, and then something like that. You know, print. And this is just one way of doing it. There could be other ways. Enter valid temperature in Fahrenheit. I think that's how you spell Fahrenheit. All right, so make sure I get that right. So now you set that, and then you take temperature as input, probably, right? And then we do an input, that. And then we're gonna do, we don't, it doesn't matter what we do, print, the temperature is, we could probably do like a conversion to Celsius, but I don't remember the formula offhand right now. So the temperature is, and then we're gonna print. So that should be good, right? But then here we wanna stay in that while loop or that type of loop until you enter appropriate Fahrenheit. So what I mean by that is that the temperature, Fahrenheit usually has to be between like, what are some valid ranges? So it's gotta be, it's usually not less than 130 Fahrenheit, right? Unless you live in like the Antarctic or something. Here we've gotten like polar vortex at 100 and, minus 10, right? Let's say minus 10 to, what's the high end of a Fahrenheit? Could be like 100. Let's say 100. I think out in the west, in the desert over there, 100, and Death Valley, I think, is like 140 at most, right? So some extreme values there. So how could then what could we do? Maybe here, right, in the condition. What do you guys think? How do we write that in there? Any ideas? Okay.
Can you repeat the question right quick?
Yeah, just, I want to input validate. I want to make sure that my temperature is within a range, right? I'm not going to leave the, I'm not going to leave the while loop until I have entered a value that is within the appropriate range, like between -10 and let's say 140 plus, positive degrees Fahrenheit. So what do you guys think?
So it's while temperature is in range of 104 to 140, you said?
Yeah, so how do we do it? So maybe just, I think greater than, now we can use those greater than that you wanted to use, right? So if it's greater than -10 and temperature
It's less than
less than what, 140?
140.
Yeah. Then while it's there, stay in the loop. Is that what we want?
Yep. So do we have to put an if? Or
Nope.
should they already know it because we already gave a range?
Not require an if.
Yeah, because we already gave a range, right?
But this is the correct range, right? We want the temperature to be greater than -10 and less than 140. So this is actually, when we have this condition, we want to exit, right?
Yep.
So then maybe we're missing something because we want to stay in the loop only when the condition is not met. So for instance, if I run this, hopefully there's no errors, and it's going to be a string actually. So so I need to actually.
Yeah, don't you got to change the input to a float?
Yep. Float. And then I'm gonna do this. Okay. And then now I'm gonna run it. All right, so if I enter a valid temperature today is like 72. So I wanna, when I have 72, I want to exit. But it did not exit, you see that? 32 is also in the valid range and it won't exit. So what could I do with my current logic to fix that? Do you think? Any suggestions? Guys, any suggestions?
Can I say like if input is in range N? I don't know.
Well, if you think about it, you're saying while in range, right? By doing this. What if you said why? Somebody wrote something. Let's see if they have the answer. Flip the signs. Okay. All right, I see what you're going with. So you're saying this, right? And this. So you're saying while temperature less than 10 and greater than 140, stay in the loop. Will that work? Can I enter 32? It didn't actually even go into the loop, right?
It didn't even give us the option to put a number in.
Hmm?
Enter the loop, right? Because then we give us.
It just printed it. So that didn't work. It's not completely wrong. It's just, I think there might be something missing in the suggestion. What if we change this and to or? And we say, while temperature is less than -10 or temperature greater than 140, stay in the loop. Do you think this will work?
We can try.
We can try, right? But the problem is it may not be going in. See, it's not going in. So we're a little bit out of time for today. So I'm gonna, although you don't have homework, work on this over. I'm gonna leave this as a little problem for you guys to play with, right? Try to figure it out. See how you would solve this one. It's not homework again, but do it. Find a valid solution, and then we will meet. We will go over this and finish it next Thursday. Please, I asked you, please do not forget your exam 1 is on Tuesday. Please do not miss that exam unless it's like you have to go to the doctor or something. Please don't miss taking an exam, okay? All right. So we're going to stop here for today, and I'll see you guys on Tuesday. Study. No homework this week, so you can study for the exam 1. Remember, we're now starting week 6, so we're getting really, now we're moving into semester. All right, I think I had a student that wanted to meet with me at 2 o'clock. If you're there and if you can stay right now, we can start now, okay? So just stay in the session if you can. Let me know. Otherwise, actually, sorry, I have to create this video, right? So what I'm gonna do is I'm gonna close, create the video, and then come back in, okay? And hopefully you're there and we can just start a little bit early. All right, so with that being said, all right, guys, so don't forget to study, and I'll see you on Tuesday.